In engineering, system integration is defined as the process of bringing together the component subsystems into one system and ensuring that the subsystems function together as a system. In information technology, systems integration is the process of linking together different computing systems and software applications physically or functionally to act as a coordinated whole. The system integrator brings together discrete systems utilizing a variety of techniques such as computer networking, enterprise application integration, business process management, or manual programming. Overview: a system is an aggregation of subsystems cooperating so that the system is able to deliver the overarching functionality. System integration involves integrating existing, often disparate systems. System integration is also about adding value to the system, capabilities that are possible because of interactions between subsystems. In today's connected world, the role of system integration engineers is important. More and more systems are designed to connect, both within the system under construction and to systems that are already deployed. Required skills: a system integration engineer needs a broad range of skills and is likely to be defined by a breadth of knowledge rather than a depth of knowledge. These skills are likely to include software, systems and enterprise architecture, software and hardware engineering, interface protocols, and general problem-solving skills. It is likely that the problems to be solved have not been solved before except in the broadest sense. They are likely to include new and challenging problems with an input from a broad range of engineers where the system integration engineer pulls it all together. Methods of integration: vertical integration is the process of integrating subsystems according to their functionality by creating functional entities, also referred to as silos. The benefit of this method is that the integration is performed quickly and involves only the necessary vendors. Therefore, this method is cheaper in the short term. On the other hand, cost of ownership can be substantially higher than seen in other methods, since in case of new or enhanced functionality, the only possible way to implement would be by implementing another silo. Reusing subsystems to create another functionality is not possible. Star integration, also known as spaghetti integration, is a process of systems integration where each system is interconnected to each of the remaining subsystems. When observed from the perspective of the subsystem which is being integrated, the connections are reminiscent of a star. But when the overall diagram of the system is presented, the connections look like spaghetti, hence the name of this method. The cost varies because of the interfaces that subsystems are exporting. In a case where the subsystems are exporting heterogeneous or proprietary interfaces, the integration cost can substantially rise. Time and costs needed to integrate the systems increase exponentially when adding additional subsystems. From the feature perspective, this method often seems preferable, due to the extreme flexibility of the reuse of functionality. Horizontal integration or enterprise service bus is an integration method in which a specialized subsystem is dedicated to communication between other subsystems. This allows cutting the number of connections to only one per subsystem, which will connect directly to the ESB. The ESB is capable of translating the interface into another interface. This allows cutting the costs of integration and provides extreme flexibility. With systems integrated using this method, it is possible to completely replace one subsystem with another subsystem which provides similar functionality but exports different interfaces. All this completely transparent for the rest of the subsystems. The only action required is to implement the new interface between the ESB and the new subsystem. The horizontal scheme can be misleading, however, if it is thought that the cost of intermediate data transformation or the cost of shifting responsibility over business logic can be avoided. A common data format is an integration method to avoid every adapter having to convert data from every other application's formats. Enterprise application integration systems usually stipulate an application-independent data format. The EAI system usually provides a data transformation service as well to help convert between application-specific and common formats. This is done in two steps. The adapter converts information from the application's format to the bus's common format. Then, semantic transformations are applied on this.